take those terms away, put letters there, and ask yourself, what is this, what is that, okay? Same with up the top. This is more of an industrial type building. This is more of a domestic type building.
Can you go back to the industrial one? Girts, they're both steel and wood in a real situation? They're the ones that go across.
Yeah, a girt is basically anything that is stuck on the side of the building. You can have a girt that is actually not sheathing. It can be the piece that the sheathing is actually fixed to. So it can be a wee lug or something on the side of the building that you're fixing the sheathing to. So
so they're not always
no, not always horizontal. They can be all the way along. In fact, I guess these days a lot of industrial buildings are built a wee bit like the domestic buildings. They have to have an air gap, even though there's not necessarily people inside there living in there, but they still build them to the code. Questions? Get there in a minute. Okay. So with plate design, I'll turn I think we'll do this slightly different. I don't think I'll show you this. Yeah, okay. So what I'm going to do is I'm going to copy that onto the whiteboard, right? And I'll scribble the answer up here at the same time. So I'll copy these onto the whiteboard to give me some whiteboard space. Okay, so the first one that we've got, see if I can take my jersey off without exposing my, that'll be a shock as well. Okay, 500 by 400. So the plate itself is 500 by 400. There's 1, 2, 3 holes. All right. So the clues to plate design. If I say some silly things from time to time on this course, but the reason for doing that, and a lot of international students don't quite understand why I will say something silly like a grandmother's quilt, for example. A lot of them don't understand what a quilt is, and a lot of them don't know why I'm saying it. But to some, it's kind of something that jogs a memory of going to grandmother's house and seeing a quilt on the bed, rather than what you might find a duvet or something nowadays. And grandmothers in the old days used to make the quilts. Now you just nip down to Briscoe's or something at half price and buy them, right? So they used to sew the quilts, and they would sew right around the outside edge to give the quilt the maximum strength possible. So no matter what little bugger of a grandchild I was jumping all over the bed, I never ripped it, right? It's the same with metal plates. The ideal way to design a metal plate is to put the holes as far to the edge as possible. So if you think grandmother's quilt, that's fine. If you want to think of it in another term, that's fine as well. So if you push everything as far to the corners as possible first, then that's how you design a plate. The problem is that every now and then you're going to breach a couple of your rules. Now the basic rules that is going to be all over the board here are your maximum and your minimum. Now, when I say it's a 16mm bolt hole, that means it's a bolt hole. It's not a 16mm bolt that has formed the hole. It's not, it is a 16mm diameter hole. So, whatever the call up is, in this case 16mm, the bolt is going to be 2mm less. Because there's always 1mm there and 1mm, well basically 1mm all the way around. So the reason why you have to calculate the bolt is because normally the person in the, when you're detailing the bolt hole, so the person that's creating the plate can put the hole into the plate. You don't just say to the person who's making the plate, oh, 14mm bolt, 12mm bolt, 10mm bolt, because then you're making that poor guy, and all he does all day is go zzz and drill a hole, zzz, drill a hole. You're making him do the same maths that an engineer should be doing to work out what the bolt hole is, right? So you don't do that to him. You tell him, as an engineer, that the hole size will be 16mm, right? So when you're detailing the hole size. So 16mm bolt hole means that is the outside diameter, and you, when you're doing a calculation for the plate, have to work out the bolt diameter. So the bolt diameter is 14mm. So the minimum is 2.5 times the bolt, which equals 14 times 14, and 14 is 28, and 7 equals 35mm. 14 plus 14 plus 7, 2.5. Or maybe that's better off. Oh, nice one. Right, so I'm going to end up with a black nose at some stage, like COVID. I'm touching my nose all day. 2.5 times 14, okay? And the maximum is going to be the thickness of that. In this case, it is, the first one is 8. So it's 32 times 8, or as we call it, 32T. But there's always another part to this one. If it goes over 300, it's not allowed to go over 300mm. So 300mm is where it gets capped off. Okay? So in this case, it is 32 times 8, which equals 256. So 35 and 256 are our two numbers, maximum and minimum. So let's push everything to the outside edge. Let's call that 35. Let's call that 35. That means we are left with 400 minus 35, which equals 330. Divide that by 2 spaces, equals 165. Down here, 500 minus 35 equals 430. Divide that by still 2 places. Divide that by 2 equals 215. 215 and 165 is perfectly fine. It doesn't go over 256. So tick, tick, job done. And yes, that was an easy one.
So if it was larger than 300 millimetres, what would you do? Just keep it as 300?
We'll get that in a minute. That'll be the last one. Yeah. So the next one is example 2 is 710 and 550. 710 being downwards and 550. This time we've got, the engineers said they want 3 on the way down, or 4, sorry. 1, 2, 3, 4. Always calculate max and minimum. Maximum is going to be, this time it is 10 millimetre thick. So we've added something else to the mix. So the maximum is going to be equal to 32 times 10, which equals 320. That's a problem because it's gone over the 300. So therefore it goes back to 300. The minimum is the same as last time because we've got the same bulk, the whole size. So once again, 35, 35, 35, 35, and 35 in the other direction, and 35 in that direction. So we're hoping that this is going to work out okay. 710 minus 70 equals 640. Is that right? Yep. Divide that by 3, and we end up with 100 and what do you get? 240 divided by 3. Obviously no one's been walking up Newmarket with a cell phone lately. Do we have somebody with a cell phone? I mean, a calculator?
213.3.
213.3, exactly. Okay, 213.3. And who said that? Was that you?
Yeah.
What's the answer to that one?
240.
So the gap between there and there.
Yeah.
How much do you get?
240.
240?
Yeah.
Okay. If you're right, you can get yourself a half a mark for that. Minus 0.35, minus 35. So minus 70 equals 470. 480. Is that divided by, yes, 240. So you are correct. So you need to email me before midnight tonight. Well, I've had a few students that don't do that. They say, oh, I forgot. And I say, oh, I forgot to give you the half mark. All right. Okay, now, Hunter, this is your question being answered, the last one. Okay, so this is more of a question, you know, because I'm such a nice person, probably find that you'd be lucky to get a question like the first two. Tends to be more like the last one. And a lot of students look at that and go, well, that was really easy. You're probably doing exactly that right now. Easiest half mark I've ever got. And then the test comes along and it's not really that easy because this next one is what quite a few of the questions are in the test, okay? Now, I'm letting you away in the assignment with just doing whatever works so that some of you who have been crying somewhat about the fact that you had the wrong plate size can come along and put both of your bolts in here and not breach the maximum and the minimum, which technically is correct, but according to plate design is completely incorrect. Okay, but I'm going to let you away with that in assignment as long as it works and as long as you detail it correctly. But I'm telling you that generally speaking, a lot of you mucked up assignment 3 because you picked the wrong plate size, okay? And I did cover that in the notes at the time, but I'm not quite sure, maybe it was because we were in lockdown, or maybe it was because most of you were still sleeping at this time of the night.
I could be wrong, but wouldn't that make the plate go a little bit too far to the, close to the edge of the concrete?
Are you talking about to try and bring the holes as far as we can take them to the side?
Yeah, I sort of, yeah, I didn't,
Yeah, so what you're saying is there actually no room for the plate, the holes over here, right?
yeah, there's not,
Yeah.
that's true.
But you're right, there isn't. And it's nothing to do with this, it's to do with you can't get it
Yeah,
far enough away from here. So you would have to put the first one there.
you've actually
But
had
in
to
proper
like
plate
that.
design, especially the students that have just trimmed off the edge to 50, there's nowhere for that to go either. So technically, they should also be putting it as close to that end as well. And when you look at it, it isn't particularly good plate design. Okay, what really should have happened was you made enough allowance on this side
Put the other one too.
to put the other one over here, and then it's, at least it's balancing things a little bit better.
Yeah, I see. Yeah, because you couldn't go left, but you could
Yeah.
go right.
The beauty about diploma level is, you know what you should be doing, you can give it your best crack, and put it under the nose of the registered engineer to sign off, okay? So, you can sit there with a smile on your face going, well, it's not my responsibility, I did my best. If they let it go by, that's their problem, right? Unfortunately, if you go on to do the degree at university, you'll be the other way around. You'll have to check everything that the diploma student does before you sign it off. So there's different levels of responsibility. Actually, as a team leader, I kind of was in between the two. So they often trusted me, so I had a responsibility of checking the diploma student had got it right, and then often they would come in and say, did you check it? And I'd say yes, and then they'd be in a bit of a hurry and sign it off. They shouldn't have been, they should have actually checked it again themselves. You'll find with drawing careers, everybody puts their 2 cents worth in. You'd be amazed at how many different marker pens there are colour-wise. Everybody seems to, you get your drawing day, it gets circulated around the office, maybe 10 people have all had input, and they highlight their bit that they want changed, and it looks like a multicoloured art picture when it comes back. It really has got, so the reason why they do that is if you don't understand something, you can go back to the person who did the purple stuff, might be an environmental engineer or something, and say what's going on here, right? So you think just drawing is a fairly boring career, but the interaction you have with everyone in the office, you know, in a day you might have interaction with 20 people just to get a drawing out the door. So it has, you know, there's a different element to it compared with sitting in the corner and doing structural calculations all day, you know. Okay, so the last one here is the one that is a bit different. So the last one's got 780 down the bottom. On the right hand side it's got 710. There's 4 again, but only 3 across. The plate size thickness is the same, it's 10 mils. So we can basically work out our maximum and our minimum from over here. So it's 35 and it's 300. Coming down this way, 35, 35, And so we're left with 710, 640. This time we're dividing it by 1, 2, 3, and we end up with 213.3. So that's exactly the same as over here. Where the difference is in this way. 780 minus 70 equals 710. We divide that by 2, and we end up with 355. And we have an issue with our maximum. So at that point, we have to come in. Grandma's quilt is no longer going to be sewn on the outside edge. We have to come in, so I'll just do that in red. And we have to come in, so we start by going 300, 300, and so therefore it is 780 minus 300 equals 480. Divide that by 2 equals 240, and I think I've done that right. 300, yes, I have. 240.
Not at 600, right?
No, sorry.
It's supposed to be 600.
600, isn't it? Yeah, correct. So 600 equals 180. Divide that by 2 and you get 90. So the red ones are the correct ones. All right?
So that plate is 780 by 710.
The plate is 780 by 710. Yeah. So if it was if we were in 112 1100, I'd have the plate showing up, and you'll be able to compare it. If you've got a laptop like the chap at the back there, you can see what I'm doing anyway. This one I'm going to do on the whiteboard on the side because you do need to see it if possible. Okay. And I'm sorry, but we'll have to play with the lighting a little bit. Not quite sure what's going on there. I think they've been setting up all these automatic videos, but I mean, this is exactly why Zoom is so much better, because this thing here is pointing at this whiteboard, which is not picking that up, but it's picking up the whiteboard. And it's probably picking up all the crap that's coming out of my mouth, I'm not sure, but and if we did it over here, it might pick up some of it, but the thing about Zoom is that it's picking up my voice, it's picking up your questions, it's picking up what's on my monitor, and then if I show something else, it's picking that up as well, and you can go back in your own time and go over it. So I've been experimenting with the surveyors. They have 2 classes. One we come into Unitec for, and the other I take on Zoom. And I'm reviewing some of their drawings on Zoom. So the whole lot of them get to see drawings being reviewed, and it's recorded. So they're getting the best of both worlds. I'm going to try and suggest that for next year. Maybe do this lecture on Zoom and then do the lab at Unitec is quite a good idea as far as I'm concerned. But anyway, it's a bit late now. We did most of the year on Zoom anyway. So what I've done as far as this one goes is the exact girder is in the test. There's around about 2, maybe 3 questions. Moodle's been set up to give you a couple of plate questions. I put a minimum in, so there'll be a minimum of 2 plate questions, a minimum of 2 of these. There'll be a minimum of, I think, 3 bar schedules as well, which is the next one we're coming to. So Moodle's been set up to give you a minimum of 2 and a maximum of 3 or 4, depending on what I put for each one. But you won't get any more than 20 questions, okay? It's also set up to give you 9 multi-choice questions as well.
So 2 bar reinforcing.
Well, 3 probably on the reinforcing, probably 2 of this, and probably 2 of the plates. But look, that's, as I said, there's a variance. So I don't want you to come up or complain to the CEO of Unitec because you've got one more reinforcing one than your friend next door. It's just the way Moodle mixes it up and the way I've done the test. Also, I've tried to pick the hard questions so that everybody gets one hard one and one fairly easy one, but that doesn't always work. I've had students that come up to me and say, I got 2 easy ones. Another one will come up and say, oh, Moodle picked on me, I got the 2 hard ones, and you find that student got like 0 out of 20, so they're pretty, everything was hard for them, right? So, you know, it swings and roundabouts. The way how this one works is I've taken a sketch, I've got rid of those, I've taken the 12 out, and put in some different numbers here and here on some of them. Like obviously if I've kept that angle, then that number 14 will still be the same. But if I've changed that, then that number will change, right? So I've mixed it up. So you can't just say, oh, I know how this works. It's going to be exactly the same. It's going to be the same chart as the answer that I'm going to put on the board, because it's not, okay? But if you know the philosophy, it's just like the assignment. If you know that number there, the 210, the 122 and the 46 is the weight per metre, then it wouldn't matter what I put there, you would be able to use that weight to calculate the beam size, right? I think what I'll do is I'll do the reinforcing on that board. I think what I'll do is I'll open up the answers to this. Because this one is fairly straightforward. Okay, so there's the question that you had in terms of answering it goes. And down the bottom is the actual answer. So if I just go out a wee bit, you might be able to get the whole lot in there here. So the one is how many of them are there. So this diagram will not change. So there will be some form of similar member on top. There'll be a similar member here, here, and here, but a different size. Okay. The length, well, that's going to be taken from up here. So if that changes, that number will change. The 46 and 122 is the last number here and here. And if you get that philosophy in your head, then it wouldn't matter what I put there, you'd be able to do that quite simple. So these two numbers should be easy to calculate. The angle, the length of the angle is calculated, I'm sure I'm going to knock that over, but never mind, we'll put it here. What you've got to do for this particular one when you get the answer in the test is you need to work out that distance there, and that distance there is always going to be using that 21.3, which is the big T. So whatever big T is, in this case it's 21.3, 21.3 is, but two of them are taken off that overall height. And the overall height is that number there, 533. A little bit blurry, I can assure you it is 533. Now, that number there may change, but the philosophy of, and also big T may change, but the philosophy is very simple. 533 minus 21 minus 21. 0.3 minus 21.3 equals 490.490.40. So that's how that's done. The 14 is from here, and that may change if the angle size is different. Lastly, the plate. The hardest thing that students muck up with the plate is they get their length and their width in the wrong place. So the length is the first one, the width is, the length is the second one, not the first one. The width is the first one. Okay? So often in a case where I put F, students go, oh, that'll be 500. When in actual fact it is, F is, no, they say that'll be 250, when in actual fact it's the 500.5. And I guess the meanest one would be N. So if Moodle starts picking on you, that'll be the one you'd have to calculate on this one. Alright? If you do get that, leave it to the end. Alright? You might find with a 50-minute test you've got plenty of time to do that, but you might find you've killed all your time and at least you've only got one more to go. Don't spend ages doing that. 15 minutes is roughly 2.5 minutes per question. You should be able to bowl through the multi-choice at the rate of about half a minute to 3/4 of a minute per question. You'll either know it or you won't know it. And that should leave plenty of room for the calculations. My top students leave around about the 30-minute mark, along with the bottom ones. And then there seems to be a lot of average students or the middle students still hanging around at the 15-minute mark. Don't play with the devil like a lot of you love to do with your assignments, and wait till, I'm not just looking at you guys, but you know, let's just wait to the very last second and see what we can do. Oh, it's closed, and then in come the emails. I'm only 1 minute late. Please let me off the penalty. Yeah. So don't do that, because what happens when you do that? I don't know. I actually genuinely don't know what happens if Moodle bums you out. I'm not sure whether it saved the last one or it was the last time you saved. You know, some of you might have been just going through reviewing and then it bums you out, so that might be fine. So don't do that. You make sure you've got an answer in grey for each one, and then that'll be fine. All right. So I've had students that are still got 2 questions to answer, and they're in the process of answering them. They hadn't saved them, so they went, "Oh, is that 5? Is that 6? 5? Oh, I'll come back 5. I'm not sure." they haven't put any numbers in, and then they started putting them in and bang, the test stopped. And I've gone back through and there's 3 unanswered questions. So, yeah, don't do that. That's, as I said, you're playing with the devil, not me. If you have got time at the end, check your rounding. Because so many students, they email me like, here's a good one, this is a degree one. Oh, I'm an A student, and I'm like, okay, yeah, wow, what do you do? I normally get A for everything, and I'm really disappointed in my result. And that I'm very sorry about that. I don't have any more spare tissues. I want you to check it right now because I know I'm right and I got them all right. You come back and the first 2 automatically that he's got wrong are rounding. Right answer, wrong rounding. So I just email back and say that you've got all your rounding wrong for the test, and that's it. And they were see in a maths test, I know what they do. They go, oh look, he's done all the sums, well done. We'll give him half a mark, didn't get the right answer at the end, right? But it's not a maths test. This is my drawing test, and you've got to be real careful that you do that right. I'll remind you tomorrow, next week, but hopefully you'll get that right. The way I was taught is 39.955, 2 decimal places, equals 39.96, right? You interrogate the 3rd one and you apply it to the 2nd one. Okay, I'm sure you guys were taught that way as well. The surveys swear black and blue, they're taught a different way, but that's the way that Moodle will mark it. Alright? This, the workings of this, or the model answers, will be made available after this class, so you'll have a whole week to go through that and figure it out. So lastly in today's lecture is the hardest one, which is this one here. So with this one here, it's exactly like grandmother's quilt. Sorry to bring that up again for those that still don't know what I'm talking about. And it's the same with your assignment. An abutment looks like this. If you were to look at it in sort of 3D, it would look sort of something like this. Alright? And that is going across a road. So when we talk about the width of the abutment, we're talking about that distance there. Not that distance.
Yeah.
No. The reason why is because we talk about it's the width of a bridge. An abutment is quite simply sits here. Here's your ground, and there's another abutment on the other side. All right, and then usually there's some sort of a pile cap down the bottom, raking piles coming off that. This is sort of shaped in here like this, and then they put the beams, roughly speaking, oops, put that out of line, through like that, with the button on the other side, right? And that's very roughly how a bridge works. So we're doing this piece here, and when we talk about the width, we talk about the width of the road. All right?
So what do you call that then, if it's not the width, that bottom bit?
I guess that's the length of the abutment, I guess. But it's going to be dimension. This is how it's going to look in your test. All right? Well, when you think about it, the length of the beam, length of the abutment is probably what it's called. I don't know the exact answer, but I'm speculating that that's how they do it. Howard company that did a lot of the bridges and the footbridges on State Highway 20 to the airport back in the days when that was just a dream, before they did that motorway down to the airport from up here. And pretty much they look like that. Except,
Yeah, they're doing them on the North Shore as well, the one just went North Coast.
yes,
Two of them.
yes. So eventually this gets filled in, and then of course the cars, you know, are driving along, and this might be a lot wider and what have you, as far as the cars go. Also did quite a bit of work on Spaghetti Junction when they changed that. That was another story, but we actually won that work because of Australian engineers coming in with a totally different philosophy to what Transit New Zealand wanted. So you're going to be given different dimensions here. So it's 1550 there on the practice one. That could be 2 metres, could be 3, could be some completely different number. Different numbers here, different numbers here. And be careful, because the 16 is obviously the diameter of the bars. So it could be 20, could be 18, could be a totally different number altogether. So don't assume it's exactly the same as this. In fact, you might even see the same dimensions and go, oh, Roger's just copied his practice one. And, you know, make sure you check everything. The other thing that makes a big difference is the width. The width of the abutment is 3.7, because if you think about it, if that width has changed, then the numbers of bars are going to change as well, right? It really isn't that much different to the retaining wall that we did at the beginning of the structural, which looked more like that, didn't it? So, yeah, it's a little bit different, but it's not really that much different. So we're pushing the bars as much as we can to the outer edge. And because the sketch is very hard to figure out what's going on, I'm going to draw you a little picture of what's going on over here. And it might help some of you figure it out. I'll use colours. So we have a bar that goes like that. And we have another bar that goes like that. Another one that goes like that.
You know what would be super helpful one day is to have a photo. Photo, so you can actually like see the bars turning in the different directions.
Yes, it would be useful. But if you get the idea of where these bars start from now, you'll probably be able to figure that out. 1603, 1604. 1605 and 1606 is the little bars there. So these bars also So if you look at the colour, you can see that they overlap in behind, pushed as far as possible to the edge. The thing to remember is that when we're calculating how many bars in this direction, we always take it, and I'll blow that bit there up, we always take it that distance is going to be equal to the centre of there is going to be equal to the cover and 2 times the diameter. A mistake that students make is they take the